This question is taken from the ENGAA 2020 Section 2 paper, and it is question 1. So we read, two springs are connected in series. Spring P has spring constant 1 Newton per centimetre. Spring Q has spring constant 3 newtons per centimetre. The total extension is 6 centimetres. What is the extension of spring P? So it would be good to draw the setup of these two springs. So P with 1 Newton per centimetre and Q with 3 newtons per centimetre. So we're told that their total extension adds up to 6 centimetres. So they both have a certain extension because they're under a certain force. So their extensions x1 and x2 must equal 6 centimetres. So this is a relationship that we can draw between them. But how can we get x1, the extension of spring P? Well, the information has given us their spring constants, and another way of interpreting a spring constant is as a stiffness constant. So it's how hard is it to extend that spring. So Q is 3 times as hard to extend as spring P. So for the same force, this must mean that Q extends 1/3 as much as P. So that must mean x2 is 1/3 of the size of x1, based on the fact that this is 3 times harder to extend. So we have x1 plus 1/3 x2 equals 6 centimetres. This is 4/3 x1. So if we rearrange this, then we can see that x1 is 3/4 times 6, which is 4.5 centimetres. So our answer is E, 4.5 centimetres. A more intuitive way to have done this without needing long algebra, even though this was actually quite quick, is that if P has 3 times the extension of Q, then if you think of the extensions divided into then 4 parts, 3 parts are P, 1 part is Q, then of the total extension, P would take 3/4 of this extension. So that's why it's 3/4 of that total extension. So you could think of this as the 3 over the 3 plus 1 parts. So we get 4.5 centimetres is the extension of P.